Well, hello. We are in our last unit of this course. This is on differentiation. So let's start with the discussion on rates. This is lesson 12.1, so let's get started. The definition of what a rate is, we've gone over that before in this course. It's just a comparison, any comparison between two quantities of different kinds. So it could be something like miles per gallon, dollars per hour, words per minute, something like that. Any time you're comparing any two quantities. All right, so here's an example. Let's say my brother and I took separate road trips and we both started at 7:10 a.m. So I travel 500 kilometers and I arrive at my destination at 12:35 p.m. My brother travels 650 kilometers and he arrives at 1:15 p.m. So it's a question of who traveled faster. So we're looking at the rates of both of our trips. My distance was 500 kilometers. Now to figure out my time, I take my end time and I subtract my start time. So that's 12:35 minus 7:10. So that's 5 hours and 25 minutes, which is 5 hours and 25 sixtieths of an hour. So that's how I wrote it. And to get your rate, we've talked about this before too, you take your distance and you divide by the time, and that gets you your rate of speed. So 500 divided by 5 and 25 sixtieths would be 92 kilometers per hour. And there's that notation again. It's not kilometers slash h, it's kilometers h to the negative 1. It means the same thing, but written differently, and it's a format that you've got to get used to. His distance, my brother's distance was 650 kilometers. His time, he got there at 1:15 p.m., which I changed to military time so that it was easier to subtract. That's why you see 13:15 there. Subtract the 7:10, which was his start time, and you get 6 hours and 5 minutes, or 6 and 5 sixtieths of an hour. So his rate is what you would get if you divide those two numbers, and that is 107 kilometers per hour. He's actually kind of speeding. If you consider the speed limits on the roads in Canada and other places where they use kilometers instead of miles. So my brother did indeed travel faster. Okay, let's talk about average rate of change. On the graph, I want to be able to estimate the average rate of change in the first 5 seconds, in the last 5 seconds, and then in the entire 10-second interval. So here's how I'm going to do that. I'm going to draw secant lines and figure out the slope of each of those secant lines. So in the first 5 seconds, I'm going to draw a secant line from 0, 0 to 540, and I kind of estimated that to be at 40. And it's okay to estimate if you're not given a formula, not given an equation, and not given the y values. It's okay to estimate. So I'm assuming that that second dot above the 5, that's at about a y value of 40. So if I figure out the slope between 0, 0 and 540, my y's are 40 and 0, so I subtract those on top, and my x's are 5 and 0, so I subtract those on the bottom, and I get an average rate of change of 8. In the last 5 seconds, that's from the 5-second mark to the 10-second mark, I've gone from the 540 point to the 620 point. So my y's are 620 and 40, so I subtract those on top. My x's are 10 and 5, and I subtract those on the bottom, and when I divide, I get 116. So now the last thing I need to do is I need to figure out the average rate of change over the entire 10-second interval. So now I'm going directly from 0, 0 to 10, 620, the very first point to the very last point. And so my y's are 620 and 0, so those get subtracted on top. The x's are 10 and 0, so those get subtracted on the bottom. And if I divide those, I get 62. So that's just a brief introduction to rates and average rate of change, how to calculate it. It's just a matter of finding slope between 2 points. If you have any questions, please let me know, and I will see you tomorrow.